Here, bringing you the IM351 Extra Practice Number 5 solutions on solving polynomials by factoring. There's a puzzle that goes with this one, so let's check that out. Here's the puzzle that goes with this extra practice. The idea with this one is that we've got a whole bunch of polynomials that we need to factor. We just have to factor them completely. We don't actually have to solve anything for this one. And then basically figure out what the answer is and write that underneath the correct answer choice here with these blanks below. So for example, question 1, if I did that one, and I only have to pick from the ones in the same row. So let's say that I found that NT was the correct answer. I don't think it is, but if it were, then I would put an N and a T down underneath the spot number 1. So these spots are always like 2 next to each other, and there's no repeats. So you just use each of these once. So without further ado, let's go on to the first question. So for factoring this one, first thing I'm always going to look for is going to be common factors. I see that we have a 3 that I can take out of 3 and 75. So let's do that. That leaves me with an x squared minus 25. I have to bring down my 3, and now I notice I've got an a squared minus b squared situation. So I can use this shortcut over here where I basically square root both of the things and put them in parentheses with a plus and a minus. So we have the square root of x squared, which is just x, square root of 25, which is 5, so x plus 5, and x minus 5. And that's as good as it gets. Finding that over in my answers, I see that that's HE right here. So I'm going to put an HE under spot number 1 down below right here. This problem, just like before, let's try taking out a common factor in the beginning. See if I can make my life a little easier. So 5, 30, and 45, all divisible by 5, so let's take that out. That leaves me with an x squared plus 6x plus 45 divided by 5 is 9. And now I notice that the stuff inside here is a perfect square sandwich. We have an a squared and a b squared kind of thing. So I might be able to use this shortcut where I basically square root both of things and put them in parentheses with a squared parentheses there with the sign of the middle term. Let me go and check it out. So if this is actually going to work, then the 5 that I dropped down still comes down here. Square root of x squared x, square root of 9 is 3. Since the middle term is positive, that's going to be a plus 3 quantity squared. Now let me just double check. If I multiply these together and double it to get the 2ab, I do actually get 6x. So this works. And now I can find my answer over on the left. That's SF right here. So that's going under spot 2 right over there. For this problem, I notice that these terms both have an x, so I can take a common factor of x out of these. That leaves me with x squared minus 49. And next up, after I bring down that x, I notice that I've got the difference of 2 perfect squares, a squared minus b squared, so I can use this shortcut again. So the square root of x squared is x. Square root of 49 is 7, so we have x plus 7 and x minus 7. And that matches up with answer choice ST over here, so 3 is getting an ST. On this problem, I notice that we've got a common factor of 2. They're all even numbers, so take a 2 out of that. That leaves us with x squared minus 12x plus 36. And now x squared and 36, those are perfect squares. This is a perfect square sandwich. So maybe I can use this a squared 2ab b squared a plus b squared shortcut. If I can, I have the 2 initially that I initially took out. Now the square root of x squared would be x. Square root of 36 would be 6. Since the middle term's negative, I would need to write a negative 6. But now let me just double check this. If I multiply x and negative 6 together and double that, I get negative 12x, which is what I started with. So it looks like that is going to be my answer. And I can match that up with NT over here. So spot 4 gets the NT. Okay, we're on to question number 5. And with that, a new set of answers to choose from. You'll notice these all have K's instead of X's in them. So let's see what I can do here in the beginning. It looks like right away I can take a 2 out of these. They're both even. And also a k. They both have at least a k to the first power. So 2k coming out of there. That leaves me with a k squared minus 4. Now k squared minus 4, that's an a squared minus b squared, so I can square root and do a plus and minus parentheses for that. So there's the 2k I took out already. There's the square root of k squared, which is k. Square root of 4 is 2, so k plus 2, and k minus 2. And that matches up with answer choice HE over here. So 5 is HE. So that's our first few letters of the riddle, the answer to the riddle. So maybe he's the first word, but I guess we'll see. For number 6, right away, ironically, it looks like I can actually take out a 6 as a common factor. So we've got 6 coming out of 54. That's going to be 9, so 9k squared minus 4. Now 9k squared and 4, those are both perfect squares, so I can use this a squared minus b squared shortcut again. So I have the 6 that I initially took out. The square root of 9k squared is 3k. Square root of 4 is 2, so 3k plus 2 and 3k minus 2. And that all matches up with ds over here, so 6 is going to be a ds. On to the next now. It looks like I can definitely take a 5 out of all of these, along with a k, so 5k. And let's see, that leaves me with k squared, and 100k squared divided by 5k, that's going to be 20k to the first, positive. And then 500k over 5k, that's going to be 100. So I have the 5k I took out initially. Factoring this a little further, I don't have to, but I could use my perfect square shortcut, or I could try to. These are both perfect squares, k squared and 100. So maybe it's one of these where I can square root both of those. Square root of k squared is k. Square root of 100 is 10. Since the middle term is positive, I'll write plus 10, quantity squared. And if I multiply k and 10 together and then double that, 10k times 2 gives me this 20k in the middle. So that is our answer. We just maybe saved a little bit of time doing it that way. So now that matches up with the very first thing up here, this hi. So I'm going to say hi to number 7. Next up, we've got this gnarly looking problem. This will be a little bit easier if I take a common factor out in the beginning though. So between 12, 36, and 27, those are all divisible by at least 3, and I think that's as good as it gets. So take out a 3. That leaves me with a 4k squared minus 12k plus 9. Now before I use AC method on this, let me just look and see if there's any shortcuts. 4k squared and 9, those are all perfect squares, so maybe this is one of those a squared 2ab b squared sort of perfect square sandwich shortcuts. So after I take this 3 down that I took out initially, I don't want to forget that, let me go ahead and square root these and see where this leads me. So 4k squared, square root of that is going to be 2k. Square root of 9 is 3. Since the middle term is negative, I'm going to make that a negative 3. Now let me just double check. If I multiply these and double it, 2k times negative 3 is negative 6k. Double that, you get the negative 12k. So this does work out. Good, because I didn't feel like doing AC method. Looking for that in my answers, I see that down toward the bottom here, OR. So this is going to be number 8, and that's OR. And that's the last problem out of this set. So we move on to the last set of 4. This set of problems looks a little bit wilder here. We've got A's and B's going on, so kind of the same factoring techniques, but you have to account for the random B variable in there as well. So we're going to start the same way we have before, though. We always try to take out common factors in the beginning. So between these two, definitely can take out a 7. And I also can take out an A, looking at letters here. And I also can take out a B. They all have at least a B to the first. So doing that, in the first term, the 7 and the B would go away, and losing an A would give me an A squared left over there. For my next term, we lose the 7 and the A. B cubed over B would give me a B squared, and that's all negative. So I've got the 7AB that I took out initially, and A squared minus B squared, well, that's literally like the shortcut. A squared minus B squared equals A plus B, A minus B. So yeah, I'm done with this one. And it looks like that answer choice is going to be WA. So that's number 9, getting a W and an A. For number 10, all these things, I can take out some common factors. They're all even coefficients, so I'll take out a 2. And they all have, let's see, they don't all have an a. They do all have at least a b squared, though. So let me take that out. That actually makes my life a whole lot easier. 32 over 2 is 16. Losing the b squared means I have 16a squared left over. Next up, 16 over 2 is 8. We have an a that is staying where it is, and the b squareds are gone, so 8a. And then finally, 2b squared, that's literally what I took out of this thing, so that's going to give me a plus 1 for that last term. So I've got the 2b squared that initially came out. I'm going to keep that. And now this next set of things, 16a squared and 1 are perfect squares. So I'm thinking maybe this is one of those a squared, 2ab, b squared situations. Let me give it a shot and see if it works. Square root of 16a squared is 4a. Square root of 1 is 1. The middle term's positive, so this would have to be a plus 1, whole thing squared. And now if I multiply 4a and 1 together and double it, I do get 8a, so this actually works. And I can pick my answer choice now. So I need a 2b squared in the beginning. There's a couple answer choices with that, but the last one here, in, has everything I need. So that's going to be number 10, in. For this problem, let me start by taking out a common factor. We can take out a 4 for sure, and these all have at least an a to the first power and a b to the first power. Taking all that out, for my first term, the 4 and the b are gone. A cubed over a gives me a squared. For the next one, we have negative 40 over 4, so negative 10. A squared over a is just a. B squared over b is just b. And for the last term, we have 4 going into 125 times. The a's are canceling, and b cubed over b gives me a b squared there. So I have the 4ab that I'm going to take down, and it looks like this is one of the perfect square sandwich sort of situations that we can use this shortcut on. So square root of a squared is a. Square root of 25b squared is going to be 5b. Middle term's negative, so negative 5b, whole thing squared. And if I multiply these together and double it, negative 5ab doubled is negative 10ab, so that works. So let me find this answer choice over on the left. It looks like that goes with AV right here. So there's number 11, AV. For my final problem, let me start, as always, with common factors. Can't take out any coefficients, but we can take out at least an a squared and a b to the first. So that leaves me with a 4. A to the fourth over a squared is a to the second. B to the third over b is b squared. So we have 4a squared b squared minus, well, this is literally what I just took out. So let me just put a 1 there. So I've got the a squared b that I can bring down. And this is an a squared minus b squared kind of situation, difference of squares. So square rooting the first thing here, square root of 4a squared b squared, that's going to be 2ab. Square root of 1 is 1, so we have 2ab plus 1 and 2ab minus 1. And all of that craziness looks like is right up here with answer choice OD. So let me put that under spot 12, and now I've got all my letters in. Now that I've filled in all those letters, let me go ahead and solve the puzzle. So we've got HE, that's he, WANTS, I think that's wants, the, odds, IN is in, we've got a his, and favor. Why does Gyro never, ever bet on even numbers? He wants the odds in his favor. Oh, I see, the whole even odd thing. And gambling odds. Anyway, that's all the time we have. Mr. Sutton, signing off. See you later.